Hello scholars, long time no see. Welcome back. I hope you guys had great spring break, although it wasn't probably, well, it was break. You guys didn't have to do any homework. Mine was okay. Just like you guys. Didn't really get to go anywhere as we need to stay home, but since weather is getting nice outside, I was able to take a walk and enjoy some air outside, so I hope you guys do the same thing. By the time you're watching this, which would have been Thursday, I'm recording this on Sunday. Hopefully the weather is going to be nice next few days in 70s and so on, so there you go. All right, so we're going to do skill 40 today. I really appreciate you guys giving me all the feedback about how the lesson's going. Most of your feedback has been really positive, so I'm glad that this has been good. You guys see all those key points on haiku. You probably already saw them. So lessons in terms of the format will remain similar. We're just gonna tweak here different things here and there. One thing will be that I don't remember, but you can just read it there. One of the feedback was that I had bad lighting. Well, sorry guys, I'm making this video not in a fancy studio but out on my dining table, and you can see this, that's the shadow of the light because our dining table had only one light bulb left, so I'm using the lamp on top of it. Anyhow, you guys can deal with it. You don't need all the fancy technology to do well in math. All you need is pencil and paper and brain. So that's what I have, and as you can see, I forgot to print, so I'm just gonna write it all on the paper and go with that. All right, skill 40. So far we've been doing all the trigonometry, and if you're a hand scholar, I told you it's a secret, but oh well. Trig is not my favorite. I'm an algebra girl, so there it is. We're going to go back to algebra world. We're going to spend some time learning about exponents and logarithm, what's the relationship between those two, and it's going to get so much fun. So before we go about skill 40, we need to review a few exponential rules. We've done this in pre-algebra, well, maybe not, algebra 1, algebra 2, so this has been repeated a few times. So let's look over what those are. If you have notes with you, feel free to look at the notes, but I am gonna, all right there. So left side, when you have a to the n power times a to the n power, notice that you gotta have a same base. What are you gonna do with the exponents when you're multiplying together? We are gonna add your exponents together. Okay, so notice over here in the example, both have a same base. By the way, this is called a base, and that's called the exponent. When you have a same base and we are multiplying, what do you do with the exponents? We go ahead and add it. So it's a 5 raised to the 2x minus third power. You added 5 minus 4x power. All right, now what do? We're just going to add all the like terms. What does it mean to be like terms? Same letters combined together and all the constants combined together. So 2x minus 4x is minus 2x. Negative 3 plus 5 is plus 2. All right. Next, what are we going to do when you are dividing with the same base? We subtract the exponent, so m minus n. Just quickly, this bothers me. So here's the thing about rules. You can memorize the rules and then use it, but you know, if you know the quick trick, go ahead and use it. What do I mean by that? Let's say the problem was 2 to the third power divided by 2 to the fifth power. Do you guys know that means you have 2 times 2 times 2 divided by 2 times 2 times 2 times 2 times 2? Yeah. So when you have a common factor, can I go ahead and divide it? I mean, cancel out. Yep. So I'm left with 1 over 2 squared, which is going to be 1 over 4. All right, when you do this math, guys, would it be fast to do 3 minus 5, which is negative 2, and then flip it? Or would it be faster if you just see it? Okay, 5 is bigger than 3, so just take that 3 from 5, make it 2, and then just get to that step. Notice how that's a lot faster. So, I mean, frankly, I don't really subtract it. I just see which one is a bigger number and then subtract it and leave it wherever that is. So that's the tip that you should use. All right, let's look at the example over here. For this problem, it looks a little complicated, but what I'm going to do is I'm just going to combine the numerators together, combine the denominators together, and then take care of it. So numerators first, same base, and you're multiplying it. So adding your exponents. What is x plus 3x plus 4? What's x plus 3x? 4x plus 4. All right, your denominator 2 raised to multiplying same base, add your exponents. 2x plus x is 3x, 1 minus 5, negative 4. Are we good so far? I was a little fast, but hopefully you guys can keep up with that. Now what do? We subtract the exponent. So for this one, we can't really use a trick because your exponents have the variable x and the constant, so it's kind of complicated. So being that said, I'm just going to subtract it. All right, so 4x plus 4 minus 3x minus 4. I made a huge mistake there. Huge. Like 95% of you will make mistake. What is that? Did you guys find it? Where? I can't really see what you guys are saying, but I hope that you're telling me that I need to put the parentheses around what I'm subtracting. Okay, so make sure you put the parentheses around it. Why is that important? Because technically now this becomes 2 raised to the 4x plus 4, and then I gotta distribute that negative sign inside of the parentheses, so it becomes negative 3x. What's negative times negative? Plus 4. That is very important that it becomes plus 4 there. So that equal to 2 raised. So now combine the like terms. 4x minus 3x is x. 4 plus 4 is 8. So your answer is 2 to the x plus 8 power. Sorry about the noise. My husband's cooking, so yep, it's a real life, guys. All right, now the next example, number 3, a raised to the m to the n power. So the difference between number 1 and number 3 is number 1, you're multiplying with the same base. Number 3, you have an exponent raised to the exponent. So you have an n of m. Well, that doesn't make sense. So what are we going to do when you have exponent raised to the exponent? We multiply. So m times n. Now let's look at the example. Just like the ones that we've been doing, I'm going to take care of one at a time. The first one first. For exponent raised to the exponent, so I'm going to multiply, meaning distribute it. So 2 raised to 3 times x, 3x. 3 times negative 2, negative 6 times. Second one, 2 raised to the 2 minus 2x. I can't really do anything. Now look at the problem. Now this problem becomes multiplying with the same base. So according to rule number 1, what do you do when you're multiplying with the same base? We add the exponent. So let's go ahead and add the exponents, combine the like terms. 3x minus 2x is x. Negative 6 plus 2 is negative 4. Ms. Major, how can you do so fast? I'm struggling combining like terms. Please, you got to review Algebra 1. Google it. Combining like terms. There are tons of video. You can watch it knowing how to combine like terms. Okay? Promise you're going to do it. Cool? Alright, so those are the easy stuff. Now let's focus on number 4, number 5, and number 6. Those are actually the most important one and the most confusing one. Alright, number 4. Look at your exponent. Negative n. What kind of exponents are there? It's a negative exponent. What do you do when you have a negative exponent? Alright, let me tell you the answer first and tell you why. When you have a negative exponent, you kind of reciprocalize. Okay, if you're a Heron scholar, you know I use that vocabulary. Reciprocalize it. That's not a real word. We make it up. So if you're a real scholar, just get with it. Okay? So what do I mean by reciprocalize it? So a, what's a reciprocal of a? 1 over a. And then that negative exponent becomes positive. Okay? Vice versa. Let's say you have something like this. 3 raised to a negative second power. What are we going to do? Same thing. You take what's your base, which is 1/3. What's a reciprocal of 1/3? 3 over 1. And then negative 2 becomes positive 2. Okay, so that's how you take care of the negative exponents. So that's the rule, but you're wondering, why does that work that way? My favorite question, why? Here's a reason why. I'm going to show you some cool pattern. I did not know this pattern before. Actually, my professor from college taught me this pattern. I was like, whoa, that is so cool. So there it is. All right, what is your favorite number? 2. Okay, I don't know. Let's say 2. All right, 2 squared. What's 2 squared? 4. 2 to the first power. What's 2 to the first power? 2. Okay, let's do one more. What's a 2 to the third power? 8. Okay. What do you notice over here? How would you go from 8 to 4? We divided by 2. We divided by 2. Then, what do you think 2 to the 0 power will be? Divided by 2 again. What's 2 divided by 2? 1. Whoa. Okay, let's do one more. To the negative first power. Divided by 2 again. What's 1 divided by 2? Half. Now, notice. Negative exponent, 2 became 1/2, and then that's going to be 1. Isn't this cool? I think so. So that actually just revealed number 5 rule for you. Any number to the 0 power is always going to be what? 1. 1. There you go. Mrs. Major, are you sure any number to the 0 power is going to be 1? Yes. All right. Whatever, I'm just typing. Raised to the 0 power. Haha, guess what's going to be? 1. Okay, so please remember, any number to the 0 power is always going to be 1. Cool. Now let's look at the example. Okay, so this one has negative 2x plus second power, negative, well, this, you can't really, I don't like this one. Can we change it? Yes. Can we make it 2 to the, no. A squared over b to the negative third power raised to the negative fourth power. I like that one better. Okay, let's do this one. I'm changing it up. What are we going to do? There are a few ways you can do it. One way, I would like to do this. I would like to take care of, well, there are many ways you can do it. But using this rule that I just taught you, if you want to get rid of that negative exponent first, reciprocalize it. So numerator becomes denominator becomes numerator, so b negative third power goes on top, a squared goes at the bottom, and then that negative 4 becomes positive 4 exponent. Alright, and then exponent raised to the exponent raised to the exponent, multiply your exponents together, negative 12, 8, and then now what are you going to do with the negative exponent? You reciprocalize. So what's a reciprocal of b? 1 over b. That 12 becomes positive 12, and then a to the 8th power. That becomes your final answer. Okay? Alright, next. I just told you a to the 0 power is 1. So let's do the example over here. Mrs. Major, there's a little problem here. What's the problem? My bases are different. One is 4, one is 2. What are we going to do? Can we make them the same base? Of course you can. What's a common base between 4 and 2? 2. So how would I write 4 in terms of base 2? 4 is 2 to the second power, isn't it? Yes, I'm going to rewrite it like that. And then keep the rest the same. Now, take care of the numerator first. I would like to do the exponent raised to exponent. That means you're going to distribute it, multiplying it. So it becomes 2 to the 4x plus 4 power times 2 to the x minus first power, 2 to the 5x plus third power. I didn't do anything yet over here. Now let's combine your numerators together, multiplying with the same base. Add your exponents. 2 raised to the, combine the like term. 4x plus x is 5x. 4 minus 1 is 3. Divide, 2 to the 5x plus third power. What do you notice over here? You're dividing something by itself. What's the answer? 1. What I wanted you guys to tell me was, oh, you're dividing, so you subtract it, then exponent becomes 0, but this is what I left them to. Okay? Alright, last but not least, number 6. We kind of touched this on algebra 2 of the radicals and all that. Alright, when your exponent is, when your exponent is rational expression, which is the fraction, what is my camera there? Please remember that your denominator is going to be the root and your numerator is going to be the regular exponent. What do I mean by that? A to the m over n power exponent is going to be, n becomes the root, right? So it's going to be nth root of a to the m power. Okay? So let me give you a quick example. A to the to 2/3. How would I simplify that? A to the 2/3. All right. That denominator of the exponent becomes the root, right? So what's the denominator? 3. So that means the third root of a squared. Or you guys can write it as a third root of 8, and then that square can be written outside of everything. These two are the same expression, so which one ever you want. Personally, I will do this one for this particular problem because that makes my math easy. So what would you do? Quick review, how do you simplify the nth root? You make a factor tree just like the square root. So what goes in 8? 2 and 4. 4 is 2 and 2. And instead of circling group of 2, which you do it for square root, what kind of root is this? A cube root. So how many would you circle? 3 at a time. So what is cube root of 8? It's going to be just 2. So this becomes 2 squared. That's a square outside. So 2 squared is 4. If that was fourth root here, you need to find a group of 4. Okay? Alright, now let's simplify this one right here. Once again, my bases are different, so I need to make a common base. 3 and 9. What's a common base of 3 and 9? Probably 3. So the first one, I'm going to keep it the same. However, my second one, 9 is 3 what? 3 squared raised to the x minus 4th power. Keep it going. 3 raised to the 2x plus 2nd power over here. Exponent to exponent, multiply it, which means distributing it. 2 times x is 2x. 2 times negative 4 is negative 8. Now look at inside of the radical. I have a 2 things multiply the same base. That means we're adding the exponents. 2x plus 2x is 4x. 2 minus 8 is negative 6. Okay, alright, I'm going to do something a little tricky. Guys, over here, when it's a square root, what number is it here that it's usually hidden for the square root? It's actually 2 over here. Why? Square root means you have a couple groups of 2 there. So if I were to write this as a rational exponent, which is the fraction exponent, how would I write it? Alright, please remember, nth root becomes your denominator of the exponent, and then your numerator becomes 4x minus 6. Okay, alright, what's now divided by 2? It's going to be 2x minus 3. That is going to be the answer. Okay? Alright, so those are the extra, all the rules that we need to know in order to do the problems on your next page. If you have a pulled out key out and if you feel like you're struggling a little bit, I highly suggest you try doing number 1 through 3 first. What I'm going to do here is I'm going to kind of tackle a little difficult problems starting with number 5. So there is the problem. Alright, before I go on, one thing you guys really need to remember is that exponent problems, I'm telling you, there are so many different ways to solve it. So I can show you one way of doing number 5, and that might be different than how Mr. Bayer would do. That might be different than how you name whoever it is. So everyone's going to do this problem differently. I'm just doing it in a way that makes the most sense for me, which might not make the most sense for you. So just stick with the method that works for you. If you get stuck, please email me. Come to my office hour and all that so you can get help. Okay, so that's going to be a little confusing part of trying to understand what everyone else is doing when you think that's not the right way of doing it. But the key is we're all going to get to the same answer. Okay, all right. So number 5, there it is. What am I gonna do? I would like to, let's see. Some of you want to get rid of the negative exponent first. Some of you like to take care of inside of the parenthesis first. I would probably take care of that negative exponent first. Okay, so I'm gonna just make that 3. That means I'm gonna reciprocalize it. So that numerator becomes a denominator, and the denominator becomes a numerator. Cool? Alright, and then what am I going to do? I am going to take care of inside of the parentheses second. Alright, so let's do the x's. Do you see x to the 5th power divided by x squared? I'm probably going to subtract it. 5 is the bigger number, so this is the easy one. 5 minus 2 is 3, so it's going to be x cubed. What about y's? Alright, I have y to the square divided by y to the negative 3rd power. I'm dividing, so what I'm going to do is I'm going to make that negative positive by going over up. So it's going to be y squared times y to the, what happened when you put it up? It becomes the positive. So y cubed there. And then you just add it, y to the 5th power. Miss Major, that was confusing. Any other way I can do it? Sure, you can just subtract it. What's 2 minus negative 3? 5, right there. To the 3rd power. And then that becomes, now it's exponent raised to the exponent, so I'm going to multiply it. X to the 9th power, y to the 15th power. Okay? Alright, now let me do number 6 with you. What are we gonna do over here? Let's see. Can I simplify anything inside of the parentheses? Not quite. So I am going to distribute that 2/3 exponent to the all of my bases. Alright guys, I know you don't really see it here, but when you don't see the exponent, it never hurts to put 1 there, because that helps you to minimize the mistake. Why did I put 1 there? Now I'm going to distribute all those exponents, meaning I'm going to multiply. So a to the 1 times 2/3, 2/3. X to the 3 times 2/3. 27 to the 1 times 2/3. Y to the 6 times 2/3. Okay? Alright, let's simplify it. A to the 2/3. 3 times 2/3 is 2. So x squared. 27 to the 2/3, y to the 6 times 2/3 is 4. X and y are probably finalized. Now let's take care of this 8 and 27. Alright, notice my exponent has a 3 as a denominator. So that means it's going to be cube root of, why? Because denominator becomes the nth root. 8 squared. Divided by 27. Has a root of 3, so cube root of 27 squared. And let's keep the other the same, like that. Alright, now equal to, what it would be? Cube root of 8. What's cube root of 8? Some of you already know that's 2. Okay, so this is 2. What's cube root of 27? 3. Alright, why? You can make a factor tree. The circle groups of 3, it's going to be 3. So what's 2 squared? 4. 3 squared? 9. Keep the rest the same. There's the answer. Okay? Alright. Do me a favor. Pause this video. Please, please, please. Pause it, and I need you to try number 7 on your own. And come back. Promise me. Do it. Alright. I hope you really tried it, because that will make me mad if you didn't. I'm going to just look at the key together and then kind of explain answers. By the way, 64, a to the 6th power divided by 125. Very similar to how we did number 6. So I distributed, well, first thing I did was, I didn't do this, but someone did, was to take care of the negative exponent. So instead of negative 3/2 as exponent, they made it 3/2 and reciprocalize it. So notice that denominator becomes numerator, the numerator becomes denominator first. And then distribute that exponent of 3/2 to all of my bases. And denominator is 2, so that's a second root. This is a square root. What's a square root of 16? 4 cubed is 64. Same thing over, that's a square root of 25 is 5. 5 cubed is 125, and the rest. That's the answer. If you didn't really feel good about it, pause it, try number 8 again, and come back and with the check with your answer. I'm not going to go over it, but that's how you do it. Okay, so that was good. Now let's look at those 2 problems at the bottom. Direction says rewrite each of the following expression as a single exponential form of d to the n power. Notice your base is 25 and 5, not the same, so I need to make it the same base. What's the common base of 25 and 5? 5. All right, 25 is 5 to the what power? Second power. And keep the rest the same. What number is that? X minus 2. Okay. And then keep it going. All right, 5 exponents to the exponent. We distribute it. 2 times 3x is 6x. 2 times 2 is 4. Times 5 raised to the distributed. X times 3 is 3x. Negative 2 times 3 is negative 6. Combine it. Multiply the same base. Add the exponents. 9x minus 2. Oh, that was super easy. I don't know why I asked you to do that. Oh well. All right, next problem. Cube root of, my bases are 8 and 2. Common base is 2. So 8 is 2 to the what power? Third power. That was the key there. 2x minus, and keep the rest the same. Equal to cube root of, oh, it keeps like, all right. Exponent to exponent distributed. 3 times 2x is 6x. 3 times negative 1, negative 3. 2 to the 3x minus 6. Cube root of, dividing, you're subtracting it. So 2, 6x minus 3. Let's subtract it, guys. What's the important thing you have to remember? Minus parentheses. 3x minus 6. Parentheses. Okay? And cube root of 2, distribute the negative. 6x minus 3 minus 3x plus 6. Cube root of 2, combine the like terms. 3x plus 3. Keep it going. What are we going to do now? Oh, that's an nth root, so when I put it in an exponential form, it's going to become the denominator of the exponent. And that means you divide everything by 3 over there for the exponent, x plus 1. Cool. Alright. Once again, there are a bunch of problems on the filled out notes or empty notes that you can try it. I highly, highly, highly recommend it. What is your IP? Your IP is number 1 through 6. 1 through 6, all of them. When you look at the key, guys, you're going to notice that it does not have the, I don't know how the answer was going. Anyhow, it's not going to have the full key. So make sure you try everything, do as much as possible, and when you submit the IP, there's going to be a vote where you can tell me which problem that you would like me to go over for the next video, and I'll try to do that. Okay, so number 1 through 6 of skill 40. Okay, all right, good luck. See you later. Bye.